Intrepid is a new way to build behaviors for your robots. It doesn't try to imitate ROS or any of the many custom workflows. Instead, it aims to give you a better, more streamlined experience when creating applications for your vehicles, ground stations, and critical robotic systems. Intrepid is built around visual programming, but it can be seamlessly combined with coding, as you will see in this session. In this release, we have made Intrepid a lot faster and easier to use. If you love robotics and software, it's worth taking the time to explore how Intrepid works, what you can build with it, and how it can make your development more productive and fun. Let's get started. So the very first thing you want to do is heading to the website Intrepid.ai and download the Intrepid agent, which is of course free of charge. The next thing you want to do is heading to your code, because in this session I'm going to show you how to integrate pretty much any function, so your standalone application as well as your ROS node, whatever is running on your robot, whatever is the stack that you use, you can do so, and you can register this code into Intrepid and expose that function as a node. So the very first thing I prepared is this run demo with a bunch of functions. These are simple Python functions, of course. As you can see here, these functions have a certain number of arguments of a certain type. In this case, we have 2 integers, and this function returns another integer, which is given by the sum of the 2 integers, and so on. You can go through this list of functions. Here we have functions with the default values. We can have functions with custom types, where a custom type can be declared by inheriting the base model and declaring whatever is the fields with whatever type you need. There are asynchronous functions, as you can see here. This is using an async IO package. You can have nodes with feedback. I will explain what the context means in a minute, and so on. The next thing you want to do is by using the Python SDK, the Intrepid Python SDK, but you can also do so in C, C++, Rust, and we are going to support other languages as you require. You define the runtime, so you create an Intrepid runtime. You can give it a namespace, but that's optional. At this point, once you have the runtime, you can import all your functions that you need, or build your own functions here. And the next very thing that you need to do is register those functions to the runtime. So runtime.register node, and these are all the functions that I have just created up here, right? You can also register a type. If you have a custom type, there is a function that is using custom types, for example, this one. And so it's, of course, you have to register that type as well, and then the function that is using it. If you want, in this particular case, you can also rename or label nodes with other names that are probably easier to remember. So in this case, a node with complex types function will be called complex types. And so the next thing that you want to do is, run that node. So this is just a Python run demo. So when you do so, you are essentially exposing all these functions to localhost 8766. And the next thing you want to do is telling the runtime, the agent, so Intrepid agent --web means that we are going to use the dashboard, the localhost via the browser, and the --load and the final endpoint is probably 8766. So that's essentially where these plugins are running, okay, which is the node that I run here. So if we launch this, and of course I refresh this, what happens is that now I can create my, let's say, first project, and all the nodes that I have created are all there. So simple node is here. If we take, let's say, the asynchronous node, async node, there you go, it's here. The other node with the complex types, it should be called complex types. There you go. So as you can see, you can search, and all these nodes are available in the dashboard so that they're ready to be integrated in whatever is the behavior that you're building. So let's build a simple behavior that takes a timer, sends, let's say, triggers this simple node, let's say 3 times per second, so 3 hertz. We can have another timer maybe down here and another timer down there. Well, you get the point. Let's take an async node, and yeah, and the complex type as well. That's fine. Now I usually add these debug logs just to see things happening. Otherwise, it's all invisible. So the debug log essentially is like a printf, like to print stuff, and we can, of course, decorate all these functions with the debug at the end. Now the other thing we want to do is, of course, connecting the output of these nodes to the input of the debug log so we can print it, and as you can see the types are correctly recognized. Now, at this point here, you want to create so these are vector trees, so complex types requires 2 vector. Okay, so we need to make 2 vectors. Make vector. There you go. So we make, let's say, a null vector down here, and let's make an identity vector, so like 1, 1, 1 down there, right? And so the complex types, let me remember what it does. Yeah, it's a element-wise addition of 2 vectors. Fine. All right, so at this point we have these 3 things happening at in 3 different threads. One that hits 3 times in a second. Let's make one that hits 6 times in a second. The other one that hits 9 times in a second, just to have a look of what's going on now in the runtime, right? So we hit play or run, and all of a sudden you have the execution of your entire workflow. So this is the behavior that is made of Python functions running somewhere else. Now, what you see here is a bit of metrics that you can see. These are very interesting because it gives you an idea of what's going on in real time. So this label on the edges is telling you something is triggering these 3 times in a second. This node takes 1.1 seconds or 900 milliseconds to execute, and then it triggers this other node here again at 3 hertz, and so on. So you get all the statistics, let's say, during runtime. And then, of course, you can also inspect the logs, if any. That's why I added these logs, to just make things interesting and easy to watch. So as you can see here, we are printing a vector, which is a 3-dimensional vector. And there is one other thing that I want to show you, that is a async node, even though it runs at 6 hertz, so it's double this. So we should expect something like double the messages as this. But this async node, if you look at the body of that function, is sleeping for 200 milliseconds, and then it returns the sum, which is exactly what happens here, because 200 milliseconds is exactly the duration of that node, which means that it's indeed sleeping well. So then we stop. Another thing that I prepared for you is this ROS node. This is an implementation of the ROS node in Python using RCLPy, which is a ROS client. But of course, we can do that with pretty much any client in any language for ROS. So I created this persistent publisher. I think this is on one of the many open source repositories that I found. And what happens here, I created this publish message, which is the method that actually publishes the message to the topic, right? And so when we initialize this persistent publisher, we are essentially creating a ROS node to pass the topic name as a string, and then we use the internal method to publish new messages to the same topic, right? Now, I want to explain this because in this, I want to explain the context. What is that? So I created this function, which is the function that I'm going to register, as you can see down here, to the runtime, okay? So the execution of this function, actually the registration of this function is like 2 lines of code. Declare the runtime, runtime.register node. and then of course some accessories like, you know, rename the node, whatever. But essentially that's these two things that you need to do. Now, what's this context thing? Well, the context is essentially a blackboard or a whiteboard. I never remember. But essentially is a place that you use to store things that you want to initialize only once. So the first time you enter this function, we are creating the persistent publisher, and we are adding that persistent publisher to the context, okay, to this CTX. The next time we enter, of course, the context is not going to be none, and so we just call the persistent publisher, we return it from the context. And then on that persistent publisher object, we call the publish message. So this essentially allows you to do a lot of things, very interesting things. For example, you declare something that is persistent, is always there, and the first time that you enter the function, from the second time onward, you just keep reusing what you have initialized the first time. So it's a very convenient way. It's also a very convenient way to, for example, in the previous example, to have these nodes with feedback. So you can essentially update the context, okay, with a feedback that is a message that the function is returning to the context. So it's a nice way to say, hey, this function is doing something, but as it does something, I can give some feedback back to the runtime, and eventually, you know, you can see or you can consume whatever that function is returning as it executes. So back to ROS, that's it. We have this publish to ROS. So we register, as I said, runtime.register node, we're done. So one thing that I want to do, let me show you this. So we have now a ROS2 demo. Actually, let's do it here. No, oh, I killed the runtime. No problem. So ROS2 demo. I launched the ROS2 demo. And what happens now is that, as usual, the ROS2 demo is running on 8765. So I connect the runtime to 8765. And now what I can do is, well, I create a new graph in which I want to have the ROS publisher. As you see, it has been exposed there. You can already use this thing. So we can do the usual, let's say, timer. So this is a trigger that, let's say, 3 times per second. To the chatter topic, you want to send hello from Intrepid. Of course, we can pass this topic or messages from somewhere else in the graph. You know, I'm just simplifying here for the sake of time. The usual debug log. We connect the debug log, and we connect also the output. So the output is something that I did for, you know, it returns a Boolean that when the publication of the message is done successfully, this Boolean, of course, is set to true. Otherwise, it's set to false. For whatever reason, something can happen on the topic in the ROS ecosystem. So we just return a Boolean to, you know, kind of a return value that tells us success or fail. At this point, we're done. We just run this. And of course, we see here that, you know, it's a bunch of true values because, you know, all the messages are correctly published to the ROS ecosystem. Now, there is one interesting thing that you can see now, that if we go in the ROS view, this is the Intrepid bridge, essentially, Intrepid ROS2 bridge. Here we actually discover all the ROS things that we have created without knowing. So there is this persistent publisher, which, by the way, is this thing here. So this is the the ROS2 node. As you can see, the bridge discovers that. And it also discovers the ROS topic, which is the chatter, the one I created by simply adding a topic name to the node, and a bunch of other parameters and events. This is the ROS2 ecosystem that, in fact, I don't care what it is now. but it's correctly discovered by the Intrepid bridge. Now, I want to do yet another thing, which is combining two different ecosystems, so like a ROS ecosystem and let's say a non-ROS ecosystem. Think about having two services, one exposing Python nodes that do, computer vision stack or navigation or whatever, perception in general. And another is, let's say, a ROS ecosystem where you are calling other nodes that you didn't implement, and you just want to, use this stuff. And then you want these two worlds to communicate, okay, without bridges, without, complication. So basically, we want to execute different things or things coming from very different contexts and very different ecosystems into the same application, into the same behavior. So one thing that one way we can do this, let me kill everything so I start from scratch for you. So one way to do this is, well, first of all, we launch the first run demo. And here we launch the ROS2 demo. So we launch the two services. One is exposed on the 8766 and the other on the 8765. So at this point, I'm going to tell the Intrepid agent, hey, look, Intrepid agent -- web, when I use the dashboard, -- load 8765 and -- load if I can type localhost 8766, right? So at this point, I am essentially connecting to two different ecosystems. And again, these two things can be running on the same machine or on another machine, doesn't really matter. There is a network in between. Now I want to do yet one more thing, very dangerous, -- load ROS2. So this is a special thing, -- load ROS2, -- load PX4. There are several, let's say, native bridges that you can also ask the Intrepid agent to preload. And when you do that, I will show you what's happening next. So now we are in front of an Intrepid agent that is connecting to two different services that are already running down here. So let's refresh this thing and let's see what happens now. So if I search for the simple nodes from the first service, they are here. And if I search for the ROS2 publishers, they are there. So all the nodes now from all the services, they are available in the same library. Now, when I did this -- load ROS2, is because there is other things. There are native ROS things coming from the ROS bridge. And again, we have a service client, a publish and a subscriber. These are typically, under the ROS2 category, meaning that, they have been loaded because we asked to load ROS2 stuff, right? So I want to do something now. There is, let's say, let's take a simple node. Let's stick with me, just to show you that how easy it is to integrate very different things. So we get this. So on timer, let's say twice per second. On the topic name chatter, we publish hello from Intrepid. Okay. Let's have a debug log. I'm not sure I still want to use that, but okay. Here we have a Boolean. Now the Boolean, I want to convert this Boolean and convert it to an integer and pass it to the simple node, which is running in Python in the other ecosystem. So I want to do like a bool to int, so a conversion of this thing into an integer so that I can connect this here, all right? So now we are speaking, data types. At this point, I want to connect these two things because I want to say, do this and then do that. But of course, the inputs are coming from, the processing of whatever is coming out of this publisher in ROS. And what else? And then we can print a debug log down here. So we can connect this and this. This should give us the sum, I think. Let's add 5. So now this graph here is doing one very interesting thing, which is it's executing stuff from a ROS ecosystem. It is processing whatever comes out of this function. It can also be subscribing to a ROS ecosystem and take that value and channel that value into another service that is running somewhere else. And so if we run this, we're gonna get a very interesting view. So here we have the 5 plus 1, indeed 6, because it's this is true. True is converted to 1. 1 is given as input to simple node. Simple node outputs the sum of 1 and 5, and so that's why we get 6, right? And that's why we get 6. So then we can see very interesting things. All these metrics that you see here, 1,300 to 2 seconds almost. Sometimes this takes 1.6 seconds, 1.5 seconds, and so on. These are the rates of the triggers that generate these events. So this is a very interesting picture because this tells you, it gives you immediately a view of what's going on in this ROS thing, which can be a node, can be a function, can be a set of nodes. It can be a completely different system. It is, in fact, a completely different system with whatever is the complexity that you need. And what you can see is like, okay, I don't know the specifics of that thing, but I know that this thing is taking 2 seconds now, and that might be too slow, for example. Okay. Okay, I think it's like 1.8 milliseconds. It's not 1,000 seconds, so that would be 1,000 milliseconds. That would be incredibly weird. So my bad, correction on that. Yeah, it's milliseconds. Well, you got the point. It's written there. I want to do yet one more thing. So let's stop this. Now I want to use another node that is not implemented anywhere. It's part of that --load ROS2. It's like the native ROS2 Intrepid bridge. So I want to use a subscriber. So this is the typical subscriber node, okay? That tells, okay, give me, I can explore all the topics that are currently available in the ROS ecosystem that I see. So this is, and of course we have the chatter. So this is something that is native for Intrepid. It's the Intrepid ROS2 bridge. So we connect to this chatter topic, which is explored from this ecosystem. Now it's not loaded, but the one I showed you before. Then we take this message, and here we can print it also. So we can print this and connect and connect. It's going to be a string, indeed. This doesn't require any trigger, as you can see here, because you print whenever there is something on the topic. So you don't need a timer for that. It's asynchronous and event-driven. So when there is a message on that chatter topic, we will print it. So these two things now are even more complicated because you have like a ROS node that processes things, sends that processed information to another node in another ecosystem, in this case, a full Python stack. It prints something. At the same time, since we are publishing to a ROS topic, we are also subscribing from a real and authentic ROS2 subscriber node and consuming messages published from here to another side. That's very, very interesting. So, as you can see, it takes a while because there is DDS in between here, and we are consuming now hello from Intrepid, which we are publishing from there. So you see what's happening here. There is so much complexity in this very trivial example. There is DDS, there is QS, there is quality of service policies. There is a lot. but we didn't really touch that complexity because we didn't need though. We just needed to connect very different and heterogeneous pieces and technologies and just make them work into one behavior. That's it. So if you are interested in this, it would be nice to try. You just download Intrepid Agent from Intrepid AI. You don't need to sign up, you don't need to log in. It's not required unless you really need it. We're going to add a few features where, of course, you will need a login. But for the time being, you can just download this and try it on your machine. And of course, get us some feedback. We're really happy to help and, of course, to know what you're building or how do you find a platform like this one. Thank you so much.